Hey, welcome. Today we're going to be beginning our magnetism unit for physics and as a basis for AP Physics courses. And I want to start out by saying magnetism is actually quite interesting. Hopefully you played with magnets as a kid or even as an older person, but even if you haven't, it's still a very interesting idea. And it really gets to the foundation of all of the motors and generators that our society uses. So we'll get there eventually, but electricity and magnetism make our modern life possible. So let's think about what people knew at different times first briefly. This is really interesting. This is part of instructions that were given to blacksmiths as to how to make iron bars or weapons or tools or whatever they are that are magnetized. So if you were to heat up a piece of iron so that more or less melted and then you shaped it, while you were shaping it you had it face north and south, due north and south. As the particles cooled down, those particles would lock into place, and as they did, they would be magnetized. Lightly so, because the magnetic field of the Earth isn't super strong, but still, it would be a magnetized bar or sword or something along those lines. And people have known about magnetism for a long time because there are naturally occurring magnetic rocks or ore. So this is magnetite right here. It will attract iron on its own, naturally speaking. So the good thing about that is it's piqued people's curiosity about magnetism over the years. We couldn't foresee the great benefits that it would bring to society to learn as much as we have about electricity and magnetism, but at least the interest was there. All right, let's continue. First of all, there are different shapes for magnets, right? There's a bar magnet. That's mostly what we're going to be talking about over here. Horseshoe shape, ring shape over here. There's also a disc shape as well. Those are common shapes of magnets. And so we need to start thinking about compasses and what the magnetic field is. So first of all, let's talk about a compass. A compass, believe it or not, has a little piece of metal right here that very easily rotates, is very free to rotate. And this little piece of metal right here is magnetized. So it's itself a little magnet. So if we have a bar magnet right here and we have compasses that we put at different locations, what's going to happen is the opposite poles are going to attract each other. So it's a little hard to see, but that has an N. That red section has an N. Just like this red section over here has an N, this north pole of the compass is going to be attracted to the south pole of this bar magnet over here. Same for up here, same for over here. Now normally the compass lines up with the magnetic field of the Earth, but if there's a stronger magnetic field nearby, it will be moved so that it lines up with the stronger magnetic field. Over here we get a similar thing. The south pole of the compass will be attracted to the north pole of the bar magnet, and you see over here. Now if we did this an infinite amount of places, you would start to feel like you could get lines, and those would be magnetic field lines to get an idea of how a compass would be deflected if it were put nearby to a stronger magnet. Alright, I'm going to show you videos of how magnets interact with things called iron filings. So iron is naturally magnetic, and we'll talk about why that is in the second half of this lesson. But first of all, what you could do is take a bar magnet and put a piece of paper or a piece of plexiglass on top, put a bunch of iron filings on here, and you can shake out patterns. Like if you tap the glass or the paper a little bit, you'll get patterns that'll form, and they will give you a good idea of what the magnetic field is like at any point around a bar magnet. So to give you an idea of what I'm talking about, if I put a compass right here, let's say, the north side of the compass would point away in this direction, and again if I placed it right here, the south side of the compass would go along with this line right here, point in this line's direction towards the north pole of that magnet. Alright, and before I show you a quick video of how two magnets are going to interact, I want you to think about what patterns we would expect to see, and then you'll see this in the video. If you have a north pole and a south pole like we do right here, they will attract each other. Opposite poles of magnets will attract each other. Like poles will repel. What do I mean by like poles? I mean like a north pole and a north pole, or a south pole and a south pole will repel each other. So which image do you think shows attraction, and which image do you think shows repulsion? Alright, well if you look at the lines in between them, these magnetic field lines that are shown, more or less shown by the iron filings, then we can see that over here we're going to have the attraction. So this must be like a north and a south, or at least they're unlike. And then over here we would have repulsion. Alright, let's take a look at this video. Note, thanks and credit goes to this person down here for the video. All right, we need to talk about a couple of other things. So first of all, the magnetic field lines can be generalized to look something like this for a bar magnet. And it turns out that the Earth behaves similarly. So the Earth actually behaves like a bar magnet. It's not perfectly straight up and down, like geographic north does not correspond perfectly with magnetic south of the Earth. In other words, it's not straight up and down like this, but it's there, and it's very important for all life on the Earth in terms of our protection, but even navigation. A lot of creatures will use the magnetic field of the Earth to help them navigate. And this is another picture showing that the axis, if we looked at the axis of the Earth as being straight up and down, the magnetic field of the Earth is tilted off to the side. And in fact, it's changing quickly as time goes on and has flipped approximately, I think, 180 something times in the history of the Earth. North has become south and south has become north, which is crazy. All right, next up, we do need to briefly touch on something called a solenoid. So this is a magnet, and these magnetic field lines actually are not shown in the middle, but they do just loop through. So magnetic field lines loop through this and loop around, and the same pattern emerges if we have a loop of wire that has current flowing through it. We'll talk more about this as time goes on, but this is called a solenoid right here. If there was an iron bar in the middle, it would be called an electromagnet, and we'll get more into that later. I just want to show the patterns of the magnetic fields are going to be exactly the same. Okay, next up I want to talk about a similarity between magnetic field lines and electric field lines. We've talked about electric field lines in the past. If you're not sure about that, I can put a link in the upper right. But what's one similarity that you notice between interactions of two different electrically charged objects versus two different magnets? Well, one similarity, it's a little hard to see because it's a little small, but if you have two poles of the same type, they're actually going to repel each other, right? Well, if you have two charges of the same type, they're going to repel each other as well. And if you have opposite poles over here, like a north and a south, they will attract each other. Just like over here, if you have opposite charges, they will attract each other. And so that's what I've written out over here. All right, now let's try to think about what are some differences. So can you think of any differences between magnetic field lines and electric field lines? All right, well, one thing that is not super clear from this diagram here is that these actually loop around. They loop entirely through the device as well, which you can't see in this diagram right here. So magnetic field lines form loops, whereas electric field lines start on positive charges or at infinity in our diagrams, and they end on negative charges or they end at infinity in our diagrams like this over here. That means like off the edge of the paper. Okay, secondly, this one you probably did not know, but electric fields are produced by individual charges, whereas magnetic fields are produced by the dipole. That means the combination of a north and a south pole. Third, just the measurements of how we're going to measure these fields are going to be different. So for an electric field, that's going to be in newtons per coulomb. For a magnetic field, that's going to be measured in Teslas. All right, this is just a summary of attraction and repulsion between magnets. And lastly, I want to bring up something that's just super cool. There are creatures that can make use of the magnetic field for navigation, and even some bacteria can do this. They can have magnetosomes, which are organelles that have iron-rich magnetic particles enclosed in a lipid bilayer membrane. All right, so they have high chemical purity, narrow size ranges, species-specific crystal morphology. So these look different from different species to different species and exhibit specific arrangements within the cell. Let's think about this for a moment. Are these bacteria the greatest sculptors ever, or is something else happening here? Well, what this means is that bacteria are actually constructing these in a sense. This is called biomineralization. It's fascinating. In a way, this bacteria is kind of consuming these minerals, breaking these minerals down and forming chains of magnets. And once it does that, then it's got its own compass inside the creature. It's absolutely amazing. So this bacteria has evolved to exploit magnetism for its own navigation. Crazy. All right, and that concludes part one. I'm going to get into part two, which will be about magnetic domains and some applications of magnetism, like how we can see the northern lights, aurora borealis, fascinating stuff, and why Mars may never be a home for human beings. I'll put a link for that in the upper right. Hopefully this has been helpful. Oh, and stick around for part two coming right up.